On number 11, let's go down here. It asks you to put these in order of least to greatest, right? Least to greatest. And it gives you a hint. What's the hint that it says you should do? Kids, can you just... What's the hint? Draw the lines. So you're putting the slopes in order. You're putting the slopes in order. Generally speaking, if I give you a question like this, I'm only going to give you, there's basically 5 classifications. I usually would max it out at 5 because to me, when you're estimating, it needs to be clear which one is greater than the other one. In this case, it's pretty good. Usually the 5 I would have are these. Nah, 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 and nah. Basically, a lot positive, a little positive, 0, a little negative, and a lot negative. Just so it's super clear when you're putting them in order. This one's a little challenging because it's asking least to greatest, right? At least to greatest. So when you're doing this, the only thing that we haven't said explicitly is the last one, the instantaneous velocity at d. The instantaneous velocity at d is equal to the slope of the tangent line, is equal to the slope of the tangent line. So you draw these 5 lines in, and you have A, which is pretty positive, decently positive, a little positive, negative, and really negative. So which one's the least? E. E is going to be the least because it's the steepest in the negative direction. And then are there any others in the negative direction? C, right? So E then C. And then which one's the smallest positive slope it looks like? B or D, right? It's hard. This is why I'm saying I would usually do 5. This one is like, it's, you know, if you move this up, it might be less steep here than here. So it's debatable which one is less steep. It kind of looks like, to me, this one is less steep than this. It looks like B is steeper than D. So if you're going from least to greatest, I would do E, C, D, B, A. That's what I would do. I would have accepted, if I had given this, I would have accepted these flipped, because it's debatable. How you can do it in my head, how do I think about it? I take this and move it straight up. And if I move this straight up, like if I took this and just moved it straight up, not changing the slope. If you move something up or down, does it change the slope? Like if I have a hill here on Mount Everest, does the slope change? No. So if you move this up, it looks like D would be below. Like if I took this point and stuck it right there, it looks like to me it would be below that point. Does that answer your question?
Yeah.
Be very careful on these because a big part of these is the reading comprehension bit, which is going from least to greatest is x squared minus 2x. So we just found the average rate of change from x equals 1 to x equals 5. So what do you draw? You go from the point where x equals 1, which is right here, to the point where x equals 5, which is right there. You connect those 2 dots, and then you find the slope between them, and what do you get? What should the slope be? We already found it out. What should the slope be? 4. We already found that out. It is 4 right there. We already figured that out. It's 4. But that's what it looks like graphically. It looks like graphically. Let's go to here. Fantastic. Okay, so let's talk about this. In real life, go ahead. Time in seconds and then distance from the breaking point after a car starts braking. A car is traveling along and it brakes, and that is its distance from its breaking point. So at time equals 0, it hasn't gone anywhere yet. It hasn't stopped slowing down yet. It hasn't gone anywhere. A asks, what is the car's average velocity over the first 2 seconds? As I've said many times, average velocity is just finding the slope between 2 points. Finding the slope between 2 points. Can someone tell me the first point that we're finding? What are the 2 points we're finding the slope between? Can someone answer that question? 0, 0, and what?
250.
To 2, comma 50, right? So we need to find the slope. Can someone tell me what the quotient is we're going to compute? Can someone tell me what that quotient is?
50 minus 0.
50 minus 0 and? 2 minus 0. So you end up with 25. And what's the units on this? Feet per? Second. Exactly. Does that make logical sense? Well, let's think about it. How fast is the car going right before it starts braking? How fast is it going? Oh, so now it's going what? 25. So is it slowing down? It is slowing down. All average rate of changes is the slope between 2 points. So what did we do here? We went for the first 2 seconds. The next one asked for the second 2 seconds. Can someone tell me, who hasn't spoken yet today, what 2 points we need to work with now? What are the new 2 points? What are the second 2 points? Liana?
250.
And what?
476.
To 4, comma 76. Now, Liana, finish it for me. What's the slope there?
Okay, well, it's 76 minus 50 over 4 minus 2.
Correct. So what's that going to be? 26 over 2, which is 13 feet per second. So is the car slowing down some more?
Yep.
Absolutely. So from here to here, it is, so we'll call this one M2, 13 feet per second. So we've shown that it is slowing down. So its average speed before time equals 2, 25 feet per second. Its average speed after time equals 2 for the same distance is, well, time distance is 13 feet per second. So a very related question is this. How fast is the car going at 2 seconds? Given the numbers that are on the screen right now, without using your calculator, can you give me an estimate of how fast you think the car is going at time equals 2 seconds, just based on the long time from 0 to 2 and from 2 to 4? Relatively, 2 seconds while braking is a pretty long time. What do you think we could do to make our estimate better? What do you think we could do to make our estimate better, Liana?
Well, you could use like the 1.5 and the 2.5.
Why the 1.5 and the 2.5? They're closer to 2. You could zoom in further. So instead, let's call this right here, let's call this M3 from here to here, and let's call this M4. So M3 is the average rate of change from 1.5 to 2. So that's going to be 50 minus what? 50 minus 39.4 over 2. And what's the other one going to be? 50 what? 59.4 minus 50 over what? 2. Not 2 again, sorry. What am I doing? It's not 2. It's going to be what? 2 minus 1.5 and 2.5 minus 2. Everybody that is actually with these numbers, that is actually what it is. It absolutely should make you a little anxious to be like, that seems too exact. I have a question for you. In real life, when you end up with numbers that are really, really nice, why does that make you nervous? These are the points graphed out. If I were, we're not going to calculate them, but I'm going to connect these. The slope of this, the slope of this, the slope of this. These represents all of the average rates of change, correct? What's happening to the average rate of change? What's happening to the average rate of change? If you had to compare all of these right here, how would you compare them? What's going on? Decreasing. It's decreasing. Is decreasing. And there was something I told you last class. What do you know if the average rate of change is decreasing? What does that tell you about the function? Do you remember what it says? Concave down. The average rate of change is decreasing, so it's concave down. Is this concave down? Is it a frowny face or part of a frowny face? Yes. So notice the distance is, it's an increasing function, but it's slowing down. It's concave down. It's slowing down. It's concave down. It's going up, right? The distance is increasing. Like the car is still traveling forward, but how fast it's traveling forward is decreasing. How fast it's traveling forward is decreasing. So let's take a look at a general case here. Let's take a look at a general case. So instead of saying time is 2 or time equals 5, we're just going to say time is A, down at the bottom there. And instead of saying we're going forward by a certain amount of exact time, we're just going to go forward H to A equals H. If I wanted to know what the average rate of change was between these 2 points, meaning between this point and this point, what would you need to do first to do that? Find the coordinates, Connor. So in this case, what's the y coordinate there? If this is f of x, what's the y coordinate? Well, it's just f of what? F of a. What's the y coordinate for this one right here? F of a plus h. So what are the 2 coordinates? A comma f of a, and what's the other one? No, a plus h comma f of a plus h. Is everybody with me so far? There are 2 points. It doesn't matter what I call each value. Can you tell me what the slope is between those 2 points? What is the quotient that we would need to evaluate to get that slope? What is the quotient? Nope. Remember, it's the y values on top. F of a plus h minus f of a all over what? A plus h minus a. So m is equal to, what can we simplify there? Well, this stays f of a plus h minus f of a over what? Over h. This right here is something you're going to see over and over and over and over again. This right here represents the average rate of change between any 2 points, where if you have an a and a distance forward. Going back here, what was our initial estimate that Zach came up with? What was our initial estimate? 19. That was our initial average. And then we got it better to be exactly what? 20. How did we make it better? How did we make it better? What did we do? Yes.
We made it more exact.
How did we make it more exact? What did we do?
Intervals that were
What did we do to the intervals? We narrowed the intervals. So instead of going from 0 to 2 and 2 to 4, we zoomed in. What was the distance right here? What's the distance here between 0 and 2? What's that distance? 2. And what's this distance right here? 2. But then we zoomed in, and what did we make the time distance? A half, and what's this? A half. We zoomed in. So in this case, right here, when we're looking at this, what was our initial distance? We said our initial distance on the last problem was 2. Our initial h value was 2. And then what was our next h value? Instead of 2, what did it become? It became 1/2. We made the distance smaller. And as we made the distance smaller, you get closer and closer to the actual number. So as h went to what? We want to make h as small as we can, right? So what is h getting infinitely close to? 0. So this right here, the average rate of change is this. But if we want to make it instantaneous, what limit are we doing? The limit as what goes to 0? H goes to 0 of f of a plus h minus f of a all over h. Can you plug 0 into that immediately? No. Why not? 0, and this might also go to 0, but you definitely can't because that goes to 0. Have we done limits like this before already? Yes, we've done stuff to them. We factored, we canceled, and we get rid of h's and we calculate them. This right here represents the instantaneous rate of change at x equals a. If you can compute this limit, that is the slope of the tangent line at that point. Connor. Need two things. In order to use this definition algebraically, you need two things. What's one of the things you need to use this? You need A. You need to know where you're starting, right? Like, what's the fixed value? Where are you taking the derivative? But what else do you need?
H.
Actually, no. H just goes to 0. You don't need to know H. What about this?
Oh,
You need to know the function, right? In order to use this, you need to know, is the function x squared? Is the function x squared plus 2? The function could be anything. So in order to get a value for this, you need a function and an a value. And then you calculate a limit. A function and an a value, and then you calculate a limit. So let's see what this means. Let's see what this means with this question right here. It says, between. What are the 2 points we're finding the slope between? Can someone tell me one of them? 2, 4, and what's the other one? 3 what? 8, yes, correct. Because this is time and this is distance. So can someone tell me what quotient am I computing? What quotient? Someone knew. What? Yeah, exactly. What's that equal? 4 over 1, which is 4. And what units is that? That's 4 what per second? 4 feet per second. Now, just a reality check here. Is that a realistic walking speed? Oh, come on, make this more exact. What could you do? Go closer, right. So instead of 2.9, what could you do? 2.99 and 3.01, and do the exact same thing. Be very careful about rounding, right? Don't round. Does everybody know how to store a number on your calculator?
No.
Let me show you that. That's actually really here. If I then hit store, pick any, like I'm saying alpha p or alpha 8, because that means p, I hit enter. Now every time I put p into something, guess what it's going to be? That value. Is that super helpful?
How do you clear that?
It's going to be that until you store it as something else. It's going to be that until you... Here, can I show you something even cooler, everybody? It's going to use that wherever you are. So let's say I did this. Y equals, if I did this, alpha p x, that's a line with slope what? That's a line with slope what? P. It's stored. You can use it in other places. So when you're cruising along and you're like, okay, it's gonna be 8 minus 2 to the 2.9, right? Enter, and then what do? Store it as alpha a. That's your a value, right? You can now, every time you want to use that, just say a. H minus 2 to the 3 all over what? Now we can't cancel h yet, right? We can't cancel h. Maybe we could simplify and see what happens. You need to remember your exponent rules. What's 2 to the a times 2 to the b? Do you remember what that is? 2 to the a plus b, and it goes in reverse too, right? So go back here. What does the numerator become? 2 to the 3 times what? H minus 2 to the what? All over. What can I factor out of both things on top? So you have the limit as h goes to 0 of 2 to the third times what? 2 to the minus what? 1 all over h. Here's the problem. At the moment, do you guys have anything to do next? You really want to cancel this h out, right? Can you? No. So there are limits that you can't do this way with the knowledge you have right now. The best you can do right now, if you tried to do this algebraically, would be to see this and be like, oh, what's my only method right now? The table that we just did. Right now, the only thing you have is the table. Because is there any way for you to cancel that? I told you what the exact answer is. It's 8 ln 2. Will we get to that point? Will we get eventually to knowing how to do that? Yes. But right now you have, can you do it with limits? Can you do it with a graph? Sorry, with a table.